This is section 5.4, mean, variance, and standard deviation for binomial distributions. The term PDF stands for probability density function. So I have formulas for some statistics that we want to talk about for a binomial distribution. In the last section, we talked about probabilities. So we said what was the probability of getting 2 smokers, or what is the probability of finding 4 or more smokers in our part of 15 customers. And this time I want to talk about the average and the standard deviation. And we have these formulas here. Now these are in our formula card that we're allowed to use on exam, so you want to make sure to be looking up that formula card and seeing what's on there so you know what you do and do not have to memorize. Let's do an example. So suppose 30% of our large restaurants customers are smokers, and 15 customers are randomly selected. What are the mean, variance, and standard deviation for the number of smokers? So last time we talked about probability, and now I want to know if I pick 15, what am I expecting? What's my average number of smokers that I'm going to find from that set of 15? And that's going to be coming from the mean. My mean is mu equals NP. My N is 15, and I have a probability of each of them being 30% chance of being a smoker. And we get our average to be 4.5 smokers. So in 15 customers, I'm expecting 4.5 of them to be smokers. Let's do the variance. Sigma squared equals NPQ. So 15 times 0.3. Remember, Q is the complement of P, so if P is 0.3, my Q is 0.7. If I multiply those out, I get a variance, or sigma squared, of 3.15. My standard deviation is the square root of NPQ, or the square root of the variance. Well, we already found the variance, which is 3.15. That gives me a standard deviation of 1.775. This is useful for us because we're finding out typically how many successes are we going to have in our binomial distribution. It also tells us about minimum, usual, and maximum values. So what are we trying to find? What would be unusual in our binomial distribution? And as before, it's going to be 2 standard deviations above or 2 standard deviations below. So mu plus 2 sigma or mu minus 2 sigma. And if I want to, I can go ahead and plug in my formulas. Which we don't have to have memorized, but I do need to remember this. So we do need to recall how to find something unusual, but that's something we've seen before, but we want to keep that in the back of our mind. Let's do an example. So Mars Incorporated claims that 24% of its M&M plain candies are blue. A sample of 100 M&Ms is randomly selected. Find the mean and the standard deviation for the number of blue M&Ms in a group of 100. So if I were to pick randomly 100 M&Ms out of, like, say, their factory line, we're going to see an average of NP, or 24 candies. So I'm expecting 24 blue candies out of that 100 on average. Let's do the standard deviation. Square root of N, P is 0.24, Q is 0.76. So this gives us a standard deviation of 4.27. Now let's say our data set in Appendix B found 27 to be blue. Now that's high. It's higher than the average, but is it unusual? So the question is it unusual? And does that mean that M&M, that Mars was wrong when they said 24% of their candies are blue? So let's do our max usual value, which is going to be mean plus 2 standard deviations. So it's going to be 24 plus 2 times 4.27. Do this on your calculator, and you should be getting 32.54. So if anything above that 32.54 would be considered unusual, but the 27 is not. So it's higher than average, but not unusual. Let's say we pick 100 and we found 40 of them. That would be unusual because it is above our max usual value.